Hi everyone, my name is Pei. Welcome to the presentation of our paper on supervised improvement of audio text cross-modal representations. This paper is co-authored with Chen Subakan, Krishna Subramani, Junkai Wu, Tiago Tavares, Fabio Iris, and Paris Maragdas. With the recent advancement in language models, cross-modal audio text representation learning has become increasingly popular. The goal for audio text pre-training is to learn a low-dimensional shared embedding space between audio and natural language. Existing state-of-the-art is the contrastive language audio pre-training CLAP, which stems from the image study contrastive language image pre-training CLIP. And CLAP achieves the learning of audio text representations by having batches of paired audio and text, and then to maximize the similarity between the embeddings of the corresponding audio and text, which is along the diagonal of the similarity matrix. The advantages of having audio text pre-training is that it can relax from the constraint of a predefined fixed set of labels as in the traditional audio classification settings. Additionally, it also makes it possible for applications like zero-shot classification and cross-modal audio-to-text or text-to-audio information retrieval. Meanwhile, such framework requires a large amount of audio-text data to train. It is hard for us to collect high-quality audio-text pairs from the wild, and the publicly available datasets that are used for training CLAP contain less than 130K pairs of audio and captions. In comparison, there exist more than 400 million image text pairs for image text representation learning, so the scale of paired audio and text data is very limited. To address this bottleneck in data, we would like to propose a semi-supervised bootstrapping-based algorithm in order to help us obtain additional data for training. The idea for bootstrapping is that we're going to start with a teacher model that is pre-trained from a small label dataset. Then we're going to assign some pseudo-labels from a large-scale unlabeled dataset. And finally, we're going to train a student model with both the small label data and the large pseudo-label data. We can make this student model the new teacher model and repeat this procedure of self-labeling, so on and so forth. In particular, for audio text pre-training, we propose 3 different strategies to obtain additional data samples. We call our framework the UI CLAP. The first strategy is called the domain unspecific curation, DU curation. And the idea is we would like to match the in-the-wild audio recordings with the training captions that is used for training the teacher CLAP model. We're going to use the teacher CLAP model to measure the similarity between these in-the-wild audio clips and the training set captions. And we're going to keep the audio text pairs with high similarity to incorporate them into the improvement set. So this improvement set is going to be used to train the subsequent student model. The second strategy is called the domain-specific DS curation. Here, we assume the existence of a downstream application, and we can match the training set captions with the in-domain labels from the downstream tasks. We're going to keep the corresponding training caption audio pairs and keep them into the improvement set. So this strategy basically preserves the subset of the training set that is more relevant to the downstream application. We would like to combine both ideas of domain unspecific curation and domain specific curation, and we incorporate them into the last strategy called the augmented domain specific curation. The idea here is that we would like to obtain more data samples, and meanwhile, these data samples are going to be curated in a way for a particular downstream application. So we're going to first obtain a subset of the training captions that are more relevant to the downstream task, similar to what we did for the domain-specific curation. Then we're going to match the in-the-wild audio clips with the subset, the filtered set of training captions. So this is similar to the domain unspecific curation. Now, the domain-specific or the augmented domain-specific curation tends to produce data samples that are similar. And this is because they are curated in particular for a downstream application. And this introduces an underlying issue with the original CLAP learning objective. The CLAP learning objective has the assumption that the different data samples within the same batch should have different semantics, and therefore it is reasonable to maximize the similarity of the diagonal entries, whereas minimize the ones that is off diagonal. However, with the DS or ADS curation, within the same batch, we may contain data samples that are like highly similar to each other. For example, within the same batch, we may have two instances of dog barking. And under such cases, it is no longer reasonable to also minimize these off-diagonal entries. To mitigate this issue, we propose a soft labeling scheme by introducing the intramodal similarity that can be estimated from the pre-trained teacher text encoder and the teacher audio encoder. And we would like to perform a convex combination with these intramodal similarity with the hard label, which is the identity matrix. And we're going to use the sum as the soft label to train the subsequent student models. For the experimental setup, we're going to follow the configuration of the CLAP using the pre-trained CNN14 as the audio encoder and the pre-trained BERT as the text encoder. And we're going to train this teacher model using 128,000 audio text pairs from 4 different datasets combined. And we're going to perform downstream evaluation on 3 different datasets, ESC50, Urban Sound 8K, and 217. Here we attach the information of the number of audio text pairs that is curated for the improvement sets. As for the evaluation, we're going to perform zero-shot classification on the datasets. And first, we present the results for the CLAP teacher model. And also we can notice that with the soft label loss alone without any data curation, or the domain unspecific curation, or the domain unspecific curation with the soft label scheme, we cannot observe any significant or consistent performance across all of the 3 datasets. Additionally, with the domain-specific DS curation only, we observe a performance degrade on ESC50 and on Urban Sound 8K. This aligns well with our hypothesis that the DS curation suffers from this kind of high or homogeneous batches with the original CLAP learning objective, and this is going to get the model confused and therefore leads to the decrease in the zero-shot classification accuracy. However, after introducing the soft label loss, we observe a consistent improvement across all of the 3 downstream datasets. With the incorporation of the additional in-the-wild data samples with the ADS curation, along with the soft label loss, we observe an even more noticeable gain across all of the 3 datasets. Furthermore, we're interested in a scenario where we do not have a large amount of audio text pairs to begin the training of the teacher model. So we introduce these experiments for the subset teacher models. Here, we introduce the subset teacher, which is trained with only 10% of the full dataset containing less than 13K pairs of audio and text. And we performed the data curation and the soft label estimation using this subset CLAP teacher model. As we can see, with the ADS plus SL strategy, this student model is able to obtain a performance that is on par with the CLAP teacher model that has been trained on the full dataset. To summarize, we propose a bootstrapping-based algorithm to obtain additional audio text pairs for training the student model from an unpaired audio and text corpus. And the integration of the soft label loss and the augmented domain-specific curation further improves the results for zero-shot classification evaluation. Finally, with the subset experiments, we demonstrate the potential of the proposed method under a scarce data setup. Even if the number of audio text pairs for training a teacher model is limited, we're still able to learn high-quality representations with the teacher-student framework using the proposed data curation and soft label loss. That's the end of the presentation. Thank you for watching.